Here we need to differentiate sine inverse of 2x squared minus 1 with respect to x. We will begin by supposing that y be equals to sine inverse of 2x squared minus 1. That means we need to find out derivative of y with respect to x. Let's do that. But before doing that, what we'll do, we'll try to simplify the expression on the right hand side of equation number 1 by making a trigonometric transformation. So here we will suppose that if we consider x to be equals to cosine of theta, then 2x squared minus 1 becomes equals to 2 times cosine squared theta minus 1. Now this is an identity which is cosine of 2 theta. So that means our equation number 1 becomes y equals to sine inverse of cosine of 2 theta. Now what do we want to do? We want to make this cosine and convert it to sine. To do that, all we have to do is use the fact that if we have sine pi over 2 minus theta, that becomes equals to cosine of theta. Now since we have cosine of 2 theta, this will be sine inverse of sine of pi over 2 minus 2 theta, such that y becomes equals to sine inverse of sine will give us the sine goes away, we have pi over 2 minus 2 theta. Now we consider x to be equals to cosine of theta. That means that theta must be equals to cosine inverse of x. So replacing this value in place of theta, we get y equals to pi over 2 minus 2 times cosine inverse of x. Now what we'll do, we'll take the derivative with respect to x on both sides. So we have dy over dx, that will be equals to derivative with respect to x of the constant pi over 2, which will become 0, minus 2 times derivative with respect to x of cosine inverse of x. So this gives us 0 minus 2 times derivative of the inverse cosine function is negative 1 over square root of 1 minus x squared. So that finally gives us, so this negative and negative 1 becomes positive to make it positive 2 divided by square root of 1 minus x squared. So therefore the value of dy over dx is 2 divided by square root of 1 minus x squared. Let's move on to the next problem. We'll have to find out the derivative of sine inverse of 1 minus 2x squared with respect to x. So let's begin by considering y to be equals to sine inverse of 1 minus 2x squared. We'll take negative as the common factor within the parentheses. So we have negative times 2x squared minus 1. Now here we will use a property of the inverse trig function, that whenever we have sine inverse of negative x, that becomes equals to pi minus sine inverse of x, such that our equation now becomes pi minus sine inverse of 2x squared minus 1. So this is the value of y. Now let's take the derivative on both sides with respect to x. So we have derivative with respect to x of pi minus derivative with respect to x of sine inverse of 2x squared minus 1, which will be equals to 0 since pi is a constant, and we have already obtained the derivative of this particular function in the previous problem, which came out to be 2 divided by square root of 1 minus x squared. Therefore the derivative of sine inverse of 1 minus 2x squared with respect to x will be equals to negative 2 divided by square root of 1 minus x squared. Then let's move on to the next problem. We have to obtain the derivative of cosine inverse of x over square root of a squared plus x squared with respect to x. Let's begin. So here we will consider y to be equals to cosine inverse of x divided by square root of a squared plus x squared. Fine. Now here let's label this as equation number 1. We'll simplify the inverse trig function on the right hand side by making a trigonometric transformation. Here we are going to suppose that, let's say, x is equals to a times cotangent of theta. When we do that, then x divided by square root of a squared plus x squared, we'll try to reduce this, but this will become a times cotangent of theta divided by square root of a squared plus, so x squared will be a squared times cotangent squared theta. Now we'll take a squared as the common factor in the denominator within the radical. So we have square root of a squared multiplied to 1 plus cotangent squared theta. So this is done so that we can write 1 plus cotangent squared theta as cosecant squared theta. This is an identity. So that means we now have a times cotangent of theta divided by square root of a squared times cosec squared theta. Now since the term within the radical is a perfect square, so this was going to give us a times cotangent of theta divided by a times cosecant theta. Now the ratio cotangent of theta divided by cosecant of theta is simply cosine of theta. So that means our equation number 1 becomes y equals to cosine inverse of cosine of theta. So cosine inverse of cosine of theta, that will be simply equals to theta. Now since we took x to be equals to a times cotangent of theta, so this implies that theta must be equals to the cotangent inverse of x over a. So we'll replace the theta value with cotangent inverse of x over a. So this is the reduced form of y as given in equation number 1. Now we'll do is take the derivative on both sides with respect to x. That means we'll take the derivative with respect to x of the cotangent function of x over a. So let's do that. Now we know that if we have derivative of the cotangent function, so that is simply given by -1 divided by 1 plus u squared. So that means in our case we have x over a. So here this will be -1 divided by 1 plus x over a whole squared, but we'll have to use the chain rule, so we'll multiply it to derivative with respect to x of x over a. So this gives us -a squared divided by x squared plus a squared multiplied to, so here 1 over a is a constant, we can pull it out of the derivative. This will be multiplied to derivative of x with respect to x. Now 1a from the new denominator and 1 from the numerator goes away, and our final result will be -a divided by x squared plus a squared. So that means the derivative of cosine inverse of x divided by square root of a squared plus a squared, so this is -a divided by x squared plus a squared. Now let's move on to the next problem. We need to obtain the derivative of the inverse tangent of x divided by 1 plus square root of 1 minus x squared with respect to x. Let's begin. So here we will consider y to be equals to our function, which is tangent inverse of x divided by 1 plus square root of 1 minus x squared. We'll label this as equation number 1. We'll try to simplify the expression on the right hand side by making a trigonometric transformation. So we will suppose that x will be equals to sine theta. So when we take x equals to sine theta, such that our expression 1x divided by 1 plus square root of 1 minus x squared, so this will become sine theta divided by 1 plus square root of 1 minus sine squared theta. Now we know that 1 minus sine squared theta, that is cosine squared theta, which we obtained from the identity that sine squared theta plus cosine squared theta equals to 1. That gives us sine theta divided by 1 plus cosine of theta. Now what we'll do, we'll try to rewrite the numerator and the denominator using some trig identities. So if we have sine of theta, which is given by 2 times sine theta over 2 times cosine of theta over 2, and we can have cosine of theta given by 2 times cosine squared theta over 2 minus 1, such that if we rewrite our expression in terms of 1 plus cosine theta, that will be equals to 2 times cosine square of theta over 2. So we'll substitute these two values into our numerator and the denominator respectively. That is going to give us 2 times sine theta over 2 times cosine of theta over 2, which we have written in place of sine theta, and in the denominator we have 2 times cosine squared theta over 2. Now luckily 1 cosine theta over 2 and 1 from the denominator goes away, the 2 and 2 gets cancelled, and we are left with the ratio sine over cosine, which is simply the tangent function. So that means this entire expression becomes tangent of theta over 2. So what we can do, we go back to equation number 1, and now we will have y equals to tangent inverse of tangent of theta over 2. Now since we took x to be equals to sine theta, so this must mean that theta must be equals to sine inverse of x, such that we can rewrite our y as, so So here tangent inverse of tangent of theta over 2 is simply theta over 2, and in place of theta we have sine inverse of x. So this is the simplified form of y, which is equation 2. In a sense, we can say that 2 and 1 are exactly equal to each other. Now what we'll do, we'll finally find out the derivative of y with respect to x. So that means we have half multiplied to derivative with respect to x of the inverse sine function. So the derivative of the inverse sine function is simply 1 over square root of 1 minus x squared, and we multiply 2 to it, or 1/2 to it. So this is the value of our given derivative, which is tangent inverse of x divided by 1 plus square root of 1 minus x squared with respect to x gives us the value 1 divided by 2 times square root of 1 minus x squared. Now let's move on to the next problem. So here we have to find out the derivative of sine inverse of sine x plus cosine of x divided by square root of 2 with respect to x. So let's begin. So here we will consider y to be equals to our given inverse trig function, which is sine inverse of. So we can rewrite the expression within the parentheses 1 over square root of 2 multiplied to sine x plus 1 over square root of 2 multiplied to cosine of x. Now here what we'll do, we will replace 1 over square root of 2 with let's write it down, cosine of pi over 4 times sine x plus the 1 over square root of 2 in the second term as sine of pi over 4 times cosine of x. Now because we know that sine pi over 4, that's equals to 1 over square root of 2, and this is also equals to cosine of pi over 4. Now this is done so that we can use the property when we have cosine of a times sine of b plus sine of a times cosine of b. So this is actually equals to sine of a plus b. So in our case, a is equals to pi over 4 and b is equals to x. So that means we can write the expression within the parentheses as sine of pi over 4 plus x. The sine inverse of sine, where the sine goes away, so we are left with pi over 4 plus x. So this is the value of y, which is the simplified form of y. Now what we can do, we'll take the derivative on both sides with respect to x, which will be equals to derivative with respect to x of pi over 4 plus derivative with respect to x of x. The derivative of pi over 4, that being a constant, is 0, and derivative of x with respect to x is simply 1. So that means derivative of our given inverse sine function with respect to x is simply equals to 1. Let's move on to the final problem. So this time we will have to find out the derivative of cosine inverse of sine x plus cosine of x divided by square root of 2. Let's begin by rewriting our equation as, we'll consider y to be equals to cosine inverse of, so we have 1 over square root of 2 multiplied to sine x plus 1 over square root of 2 multiplied to cosine x. We can rearrange the terms, and that will be 1 over square root of 2 times cosine of x plus 1 over square root of 2 times sine of x, which will be equals to cosine inverse of, so in place of 1 over square root of 2, we will replace with it cosine of pi over 4 times cosine of x, plus in place of 1 over root 2, we will have sine of pi over 4 multiplied to sine x. Now this is done so that we can use, so here we are going to use the fact that whenever we have cosine of a minus b, that will be equals to cosine of a times cosine of b added to sine of a times sine of b. So if we take a to be equals to pi over 4 and b to be equals to x, then our expression within the parentheses will become cosine inverse of cosine of pi over 4 minus x. That means we have cosine inverse of cosine of pi over 4 minus x will be simply pi over 4 minus x. So this is y. Now when we take the derivative on both sides with respect to x, so dy over dx will give us negative 1. So this is the value of the derivative of the inverse cosine function with respect to x, which is negative 1.